Somebody was asking, like, is this for real, this graph? What's the graph of this red thing right here? It's what? Anybody know the graph? I mean, we did this last semester. The red thing is a what? It's a line. It goes through 0, 0, and it goes through 1, 1. Come on, guys. 0, 0, and 1, 1. Pretend like you've had algebra 1. Well, not x equal 1. X equal 1 is what kind of line? That's a vertical line. This is the line y equal x. Okay? So that's just the line y equal x, or y equal x to the first power. Okay? Look at this blue thing right here. Have we seen anything like that before? That's a parabola. This blue one right here, that's y equal x squared. Okay? So you've got a first degree polynomial, second degree polynomial. You look at the green one here where you have a 3. That is a cubic graph. So that's going to be something x cubed. So polynomials can all be graphed. This is a real busy graph, so we're not going to go much deeper than that in here. But what happens with polynomials is they have roots or zeros, you see here along the x-axis, and they're either going to go up or down on the end, and there's several things that happen in between. And that's what we're going to talk about today, is how to graph some of these, okay? So remember some of the things we did. When we talked about the form of a polynomial, it's right here, an nth degree polynomial. You've got some coefficient, x to the n minus 1, all the way down to an x to the first, and a constant term. The degree is the highest coefficient that you have, excuse me, the highest exponent that you have. So an nth degree polynomial. And then the coefficient of that highest degree, we call that the leading coefficient. Okay, if it's an nth degree polynomial, how many roots does it have? How many? N. It has n roots. Now, we're not guaranteed how many are real or how many are complex. We know that it has n roots, okay? If there are any rational roots, we know that they're factors of the what? The factors of the constant divided by what? Factors of the leading coefficient, okay? So those are all things we've done so far. And we've studied a lot about roots of polynomials. Roots are very important in helping us graph polynomials. So a root is where it crosses which axis? The x-axis, because that's where y is equal to 0. Now, when we come to a polynomial, there are only 4 things that can happen, and it's in behavior, okay? So let's look at this real quick. So I could have a polynomial that starts up here, okay? It can do one of many different things, okay? It could do something like that, okay? So here's a polynomial. How many real roots do you see? There's 1, 2, 3, 4, 5 real roots in that polynomial, okay? So you can see this polynomial on both ends, it goes upward, okay? What's another possibility that a polynomial could do? Not a straight line. I'm talking about the end behavior. Here, both ends of the polynomial go up. What else could happen? They could both go down. So I could have a polynomial that does something like this, okay? Both ends of the polynomial go down in this case. Let's do the other graphical, and then we'll come back and look at this limit stuff. So both of them go up, both go down. What's another possibility? Come on. Well, yeah, so what about it? It starts down here and it ends up here, okay? That's the third possibility. What's the fourth? Just the opposite of that. It starts up here, it does any of a number of things, and it ends up down here, okay? So every polynomial is going to have to, the end behavior has to fit one of these 4 conditions, okay? So your polynomial either goes up on both ends, it goes down on both ends, down to the left and up to the right, or up to the left and down to the right. Okay. Now, when you get to pre-calculus and calculus, you're going to learn a lot more about something called limits. We're going to use just the terminology to get you sort of familiar with it to describe what is happening with the graph. So what you see here, this says the limit as x goes to negative infinity of f of x. So it's saying as my x values go to negative infinity, which direction is x going to negative infinity? Left or right? Left. Remember, this is our x-axis, so negative infinity is over here. Infinity is in this direction, okay? So this means as my x values go to negative infinity, where are my y values going on this graph? As the x values go to negative infinity, where do the y values go? They go to positive infinity, okay? So as my x goes to the left, my y values are increasing and going up. As my x values go to positive infinity, that means as I go to the right, where are the y values going? Positive infinity as well. Okay, I'm going to need some participation here so that I know you're getting this, okay? All this means is, the way you read this, the limit as x goes to negative infinity of f of x. It says, as your x's approach negative infinity, this is my x-axis, negative infinity is this direction. As my x values go here, where are my y values going in the graph? They're going up without bound. They're headed toward infinity. As x goes to positive infinity, to the right, my y values are going up, unbounded, to positive infinity. What about this one? The limit as x approaches negative infinity of f of x is approaching what? Negative infinity, okay? Now the other thing that's sort of important here, you see this arrow, there's no equal sign. If you ever write equals infinity, that's bad math. I mean, infinity is not a number. You can't have something equal infinity. It approaches it. It goes toward that. So the limit as x approaches negative infinity of f of x, it approaches negative infinity. What about as x goes to positive infinity, where the y values go? They go to negative infinity as well. And that's sort of, I could write that a little bit better. Okay. What about in this case? As x goes to negative infinity, where are the y values going? They're going to negative infinity. As x goes to positive infinity, where are the y values going? Positive infinity. And the last case here is x goes to negative infinity, where are the y values going? Positive infinity. And as x goes to positive infinity, where are the y values going in this one? Negative infinity. Okay? So the way we'll read this, just like we said a minute ago, the limit as x approaches negative infinity, that means I'm traveling from right to left on the x-axis. This means that the y values are approaching infinity. The y values are going up. This means as x approaches positive infinity, I'm going from left to right on the x-axis. My y values are going down to negative infinity, okay? And we always use it just like this. We don't write an equal sign. We're very precise in the notation here, but all this really means is as you go to the left on the x-axis, you're going up on the y-axis. As you go to the right on the x-axis, you're going down on the y-axis. So it's just describing the end behavior of these graphs. So again, infinity is not a number, it's a direction, so that's why we never have an equal sign in that case. So if you look at this graph, what is the limit as x approaches negative infinity of f of x? As x approaches negative infinity, I'm going in which direction? I'm going to the left on the x-axis. Where are the y values going? They're going down. What's the answer here? Yeah, negative infinity. The limit as x approaches positive infinity. Where are my y values going here? As x goes to, if I go to the right on the x, where are the y values going? They're going up toward positive infinity. Okay. With polynomials, it either goes, they both go up, they both go down, or one goes up and one goes down. Those are the only four choices. What about this one? What is the limit as x approaches negative infinity for this one? Negative infinity. And what about the limit as x approaches positive infinity? Yeah, it's negative infinity here as well. So in this case, no matter which way you go on the x-axis, the y values are going down to negative infinity in both cases. So the end behavior can tell us a lot about what a function is doing, and we just need to figure out how we're going to decode what the end behavior of a polynomial is. So what we're going to need to recall is the ability to find the degree and the leading coefficient. What is the degree of this polynomial? 4. What is the leading coefficient? 5. The degree of this one? 1. Leading coefficient? Yeah, -1. The degree of this one? 0. It's x to the 0. And the leading coefficient? 0, x to the 0. Okay. So this is x to the 0, or excuse me, x to the 0. So you've got, well, it's basically 7x to the 0. Sorry about that. Leading coefficient, this is sort of a tricky one. The leading coefficient is 7 in that case. So this is 7x to the 0. This one is sort of, you probably won't see much on a test, but what's the graph of this one? It's y equals 7. What kind of line is that? Horizontal line. Okay, so that's probably going to be you're not going to see a polynomial that easy. What is the degree of the next one? 4. What's the leading coefficient? 1. Now, look at the next one. What is the degree? It's 3. Now, how do you get that? Because I'm going to have an x multiplied by a 2x multiplied an x. That's going to give me x to what power? Third power. Okay. To get the leading coefficient, I've got a negative sign right out in front. What's in front of that x? A 1. What's in front of this x? A 2. What's in front of this x? What happens when you multiply all those things together? -2. Okay. Now, alternately, you could multiply these binomials together, multiply it all out, and get your polynomial. But that's a lot of work just to get to what the first term is. So I can look at this and know that the first term is going to be whatever this times this is. Okay. So that's going to be what -2x cubed is the first term of that multiplication. Okay. So I don't have to multiply all the terms out just to find that first one. What about the next one? What is the degree of this one? The degree is going to be 3 because this is going to contribute. What's the highest power of x I'll get out of this? I'll get an x squared out of this one. What's the highest power of x I'll get over here? An x. When I multiply an x and an x squared, I'll get an x cubed. Okay? The leading coefficient. What is in front of that x? So that's a -1. And then this one is a 1. So let me back up. Let me do it this way. I have a -1 in front of that x. This is going to be a 1 squared. Okay. If you look at the coefficient of this x is 1, it's going to be squared. What's a 1 squared times a -1? -1. That's going to be the leading coefficient. So this polynomial will start with a -1x cubed. Okay. What's the degree of the next one here? That's a 4th degree polynomial. Okay. Leading coefficient. What's in front of that first x is a -1. What about the next one? 1, -1, 1. When you multiply all those together, what do you get? 1. So the leading coefficient is 1. Okay. So we've seen a lot of leading coefficients and degrees when it's in standard form. What may be a little bit new is seeing it in factored form. Okay, so you just look at basically and say the highest degree term here is an x squared and an x. That's going to give me an x cubed. To find the leading coefficient, just look at the coefficients of each x term and multiply them together to figure out what the leading coefficient is. Okay. Now, the reason we do this is because the degree and the leading coefficient tell us the end behavior of the polynomial. Yes? Well, there is nothing. There's no x to the first power. okay? So the only power of x is x to the 0 power. So the reason we do that is because the leading coefficient is going to tell us a lot about the end behavior of a polynomial. Okay, there were 4 choices. The polynomial does this, it does this, it does this, or it does this. Those are the only 4 things it can do on the endpoints. Okay, if a polynomial has an even degree and a positive coefficient, then it's going to look like this. Okay, if the degree is even and the coefficient is positive, it looks like this. What does the parabola y equal x squared look like? Show of hands. Y equal x squared. How would you graph it? Come on. It's like this. This is y equal x squared, like a touchdown, okay? So what is the degree of x squared? What is that degree? 2. Is that an even number? What's the leading coefficient of y equal x squared? 1. Is that a positive number? Yeah, okay. What about y equal negative x squared? What did it look like? It looks like this, okay? So if I have an even degree and a negative coefficient, my graph is going to look like this. Okay, so even degree, positive coefficient looks like this. Even degree, negative coefficient looks like this. If I have an odd degree and a positive coefficient, my graph is going to look like this. So what I'm just drawing, I'm drawing the end behavior. So the graph could do, this graph could do any of a number of things in between, okay? But I know if it's an odd degree and a positive coefficient, it's going to do this on the endpoints. What about odd degree with a negative coefficient? What do you think that one does? It's going to be the opposite. Okay, so that one's going to go up to the left and down to the right. Okay, so you need to keep these straight. If it takes using hand signals, that's fine. So if it's even degree, it's either going to be doing this or this. Okay, if it's odd degree, it's either going to be doing this or this. Okay, odd degree with a positive coefficient is going to be doing this if I'm the graph. Okay. And then odd degree with a negative will be doing this, okay? So let's take a look at a few examples. And this is just so you can see it written out. Sign of the leading coefficient. Even degrees, positive go up, negative go down, and then you see what happens with odd degree. The way I remember it, even is the same. So even it's going to be either doing this or this. Odd, it's going to be doing the opposite thing on both ends, okay? So let's take a look at a few examples. Look at the first one there. What is the degree of that? 3. Is that an even degree or an odd degree? That's an odd degree, okay. What's the leading coefficient? -1. Is that a positive number or a negative number? That is a negative number, okay. So graphically, what do I know this is going to look like? Odd degree with a negative coefficient. It's going to go up to the left and down to the right. So I know it's going to do this. Okay? So that means the limit as x approaches negative infinity, as x goes to negative infinity, where are my y values going here? They're going where? They're going up. Okay? As x goes to positive infinity, where are my y values going? Negative infinity. Okay? What are the zeros? What are the zeros of this function? Well, now these are the factors. What are the zeros? -2, 0, and what? -3, 0, and what else? 5, 0. That affects the end behavior, but it doesn't affect the zeros. Okay? So what we did a lot in the last section, we started with the zeros and you had to give me the factors. If I give you the factors like this, you should be able to look at it and say, well, it has zeros at -2, -3, and +5. That's going to help us in graphing a little bit later. What about the next one? What is the degree here? This is a 4th degree polynomial. What kind of number is that? Even, okay. What's the leading coefficient on this guy? It's going to be 1 times 1 squared times 3, which is 3. Most important, is that a positive or negative number? Positive. So what does an even degree with a positive coefficient look like? That's a touchdown, okay? So it goes up on both ends. So what's the first limit? What is the answer to that? It means as your x values go to the left, your y values are going up. As your x values go to the right, your y values are going up, okay? What are the zeros of this one? -2, 0, -3, 0, and what? 5/3, 0, okay? So those are all the roots to that polynomial. What's the degree of the next one? That's a 5th degree polynomial. More important, is that an even or odd number? Odd number. Leading coefficient. It's going to be 2 times 1 cubed times 1. That's 2. More importantly, I'm trying to figure out if that's positive or negative. That's a positive number. What does an odd degree with a positive look like? That's going to be this, okay? So it goes down over here and up over here. Those arrows tell you the answer to this. As x goes to negative infinity, where are the y values going? Negative infinity. As x goes to positive infinity, where are the y values going? Positive infinity, okay? What's the degree of the next one? 4th degree, which is what kind of number? Even. What's the leading coefficient? Yeah, -1. What kind of number is that? Negative. What does an even degree with a negative coefficient look like? Yeah, it's the opposite of a touchdown. So it goes down on both ends. So what are the answers to both of those limits? Yeah, negative infinity. Okay. Now, we want to use that information because that can help us when it comes to graphing. Okay. So for a polynomial of n degrees, we know that it has n roots. Some may be real, some may be complex, okay? There are at most n real roots, okay, but there will be n total. When we come to graphing, we're going to only be graphing the real roots. We won't be graphing any of the complex ones. We also know that there are at most n minus 1 turns in the graph. What do we think I mean when I say a turn in the graph? Yeah, when it changes from, say, going up to going down or increasing to decreasing. So if we look at this one, how many turns are there in this graph? Yeah, it's going up and then it goes down. That's 1 turn. It's going down and then it goes up. So this graph has 2 turns, okay? How many zeros does this one have? 3. So most likely this is a what? 3rd degree polynomial. 3 zeros and it has 2 turns, okay? So let's answer some of these questions. What are the zeros on this graph? What are they? Yeah, so -3, 0. And what is it? -2, 0. And what else? 1, 0. Okay. So what degree is this graph? This polynomial. This is a 3rd degree polynomial. Okay. Does it have the right behavior? It's going up and down. What do you think the leading coefficient is? What kind of number? Positive or negative? Positive. So this one has a positive. If it had been flipped, it would have a negative coefficient. Okay, so this has a positive coefficient, and right there, so it's positive. How many turns are in the graph? There are 2 different turns in the graph. What is the answer to the first question? The limit as x goes to negative infinity. Yeah, negative infinity, that's where the graph goes down. And what about? Yeah, positive infinity. Okay. The y-intercept is where what is 0? X is 0. Do you see the y-intercept here? Yeah, what is it? Yeah, 0, -6, right? What are the factors of this polynomial? Yeah, x plus 3, x plus 2, and x minus 1, okay? That has to come from knowing the zeros. If there's a 0 at -3, then there has to be x plus 3 as a factor. If there's a 0 at -2, x plus 2 is a factor. If there's a 0 at 1, x minus 1 has to be a factor. Okay? Now, let's write the equation of this polynomial. Okay? So this is where you have to do something similar to what we did last semester with the quadratics. So I know that this polynomial f of x is equal to, there's some leading coefficient times x plus 3, x plus 2, x minus 1, okay? It has to be in that form, okay? It's third degree, it has these three factors. What do we know that the y-intercept was? What? It was what, 0, -6? So the y-intercept was 0, -6. That means when you plug in a 0 for x, what should you get for y? -6. So what I'm going to do, this means that f of 0 equals -6. So if I substitute 0 in for x, I get -6 equal a. If I substitute in a 0 for x, I get this, okay? Just plugging in a 0 here, a 0 here, and a 0 here, okay? What is 3 times 2 times -1? -6. So -6 equal -6a. What is a in this case? A is 1. So that tells me that this polynomial that we see graphed here is just f of x equal x plus 3, x plus 2, x minus 1. Okay? So we spent a lot of time in the last section looking for the zeros, synthetic division, rational roots, okay? Now, the zeros are going to help us in graphing this, okay? So this one we started out with the graph, but if I needed to graph this polynomial, I would look and say, well, I know that it has to cross the x-intercept axis at these points, so I can graph the zeros, and then knowing that in behavior tells me a little bit more about graphing it. And we'll spend some more time graphing later today, and then also want to see you on Friday. Let's write the equation of least degree of a polynomial that passes through these 3 points, excuse me, these 4 points, okay? Now, if you look at these first 3 points, what do they all have in common? What? Y is 0. What is special about y being 0? That's the what? That's the x-intercept, okay? So that tells me that my x-intercepts are what? -3, 0, 1, 0, and 4, 0. What are my factors? X plus 3, yeah, x minus 1, x minus 4, okay? Because if, something being a root or a 0 or an x-intercept or a solution, those are all synonymous terms, okay? So this means that these have to be factors of the polynomial, okay? What degree is this polynomial? Third degree. Is that even or odd? That's an odd degree polynomial, okay? What's special about the point 0, 5? That is the y-intercept when x is 0. So the y-intercept is at 0, 5, okay? So to write the equation of this polynomial, it's going to be f of x equal, there's some coefficient that I don't know yet, times x plus 3, x minus 1, x minus 4. What other piece do I know? What piece of information? F of 0 is equal to what? 5. So I know that f of 0 is 5. You plug in a 0 for x, you should get a 5 for y. So let's do that, and I would get 5 is equal to a. When you plug in a 0 for all the x's, this should be pretty quick. All you do is just write down the numbers that you see. Okay? What happens when I multiply that right side? What do I get? What number is that? 12. So 5 is equal to 12a. So what is a? 5 over 12. So this polynomial is f of x equal 5/12 x plus 3, x minus 1, x minus 4. Now, do you remember having done this before? Similar? We did this with quadratics, okay? This is just a cubic instead of a quadratic. Remember when I said find the parabola that passes through these points? Instead of a parabola, it's just a cubic. So just a little bit extra work, but not a whole lot to getting there. So now we want to pull some things together. We want to write the equation of a polynomial, and we want to graph this polynomial. Okay? So write the equation for the cubic function passing through 0, 20 with a negative leading coefficient. 0's at -2 and at 4 and at -5. Draw a simple sketch that includes the end behavior, the x-intercepts and the y-intercept. Okay? Where are the x-intercepts here? I didn't intend for this to be a trick question, but where are the x-intercepts? -2, 0. Where else? 4, 0. And -5, 0. Okay, those are my x-intercepts where I cross the x-axis. So I'm going to graph those. So that's right here at -2, -5, and at 4. Those are my x-intercepts, okay? Do I know the y-intercept? The y-intercept is where x is what? 0, right? What's the y-intercept? Maybe I'm not hearing it. The y-intercept is 0, 20, right? Okay. That's the y-intercept. So somewhere up here is the point 0, 20, okay? That is my y-intercept. Okay. What degree do we say this is? 3rd degree, okay? What do we know about the leading coefficient? We know that the leading coefficient is negative, okay? So what does that mean about the end behavior? It's going to go up over here and down over here, okay? So is it possible to go up to do this? Yeah, it is possible, okay? So I need the graph to start up here, go through this point, this point, this point, and I need it to end down here, okay? So if I go to graph this guy, it has to do something like this, okay? Now we can spend a lot more time to say, instead of going down here, it really went down to here, or, instead of going up to this, it went up and it came down. I'm not worried about that. If you've got all of the x-intercepts, you've got the y-intercepts, and you've got the end behavior correct, that's a good graph for this polynomial. Now, how do I get the equation of this polynomial? What are the factors? Yeah, so this polynomial is f of x equals some number times x plus 2, what? X plus 5, and x minus 4, okay? But I do know one other piece of information, which is what? F of 0 is 20, okay? So when you plug in a 0 for x, you get a 20. So that means that 20 is equal to a. And you should be real quick with this. When you plug in zeros for x, all you're going to be left with are just the numbers 2, 5, and -4. Okay? When I multiply that right side, what do I get? -40. So 20 equal negative 40a. A is equal to negative 20 over 40. What number is that? Negative 1/2. So this polynomial is f of x equal negative 1/2 x plus 2, x plus 5, x minus 4. Now, if I was being mean, what do you think I would make you do? Do what? Multiply them out. But we're not going to do that, okay? So that was on the last quiz, okay? So this is fine. That's a fine form to lead this polynomial. You don't have to multiply all of this out. Now, when you look at this polynomial, it's what degree? Third degree. What kind of leading coefficient is it? Negative. That means if it's odd degree and negative, it should do what? Go up over here and down over here, which is what we saw the behavior doing, okay? So there's several things you have to put together in this unit. We'll put one more piece together when I see you on Friday, okay? But being able to look and recognize the degree and the leading coefficient and know that if a polynomial is even degree with a positive coefficient, what does the graph look like? Even degree positive. That's a touchdown. Even degree negative. It's an upside down touchdown. Even degree with a positive coefficient does what? Does this. Even degree with a negative coefficient does this, okay? So you're okay during a quiz to use hand motions. That should be fine. Yes? Yeah. Okay. Okay.